Hello there. During this session I'm going to be talking about the amount of stuff at a molecular level as required for the IB physics course. Now for those people taking IB chemistry, there's a lot of stuff that you already know. But for those people just with an IB physics course, I'm going to start off with the basics and keep it simple. So the things we're going to be introducing. First thing I'm going to introduce is the mole, and I will link it to something called Avogadro's number. Now the mole is a term used by chemists a lot like the term a dozen. It's a word which represents a fixed number. Now the mole is derived from the number of atoms present in 12 grams of carbon-12, and this happens to be 6.02 times 10 to the 23 particles. So 1 mole is equal to 6.02 times 10 to the 23. This number, as it turns out, is known as Avogadro's number. Now, Avogadro's number, if we relate it in a different manner, 6.02 times 10 to the 23 is the number of molecules of any gas present in a volume of 22.41 litres. It's the same for the lightest gas or a much heavier gas. It will always be that number of molecules within that volume. Okay, so let's try if we just apply this knowledge for a second. Estimate the number of molecules contained in a 4.0 litre party balloon of air. So from our knowledge we know that there's 22.4 litres in 1 mole of any gas. So therefore 4 litres is going to correspond to 0.179 moles, and 0.179 moles times 6.02 times 10 to the 23 will give us 1.08 times 10 to the 23 molecules in total. So we can do some calculations as well. So this is a calculation triangle which some people appreciate, and it shows that Avogadro's number would be equal to the number of particles divided by the number of moles, which equals Avogadro's particle number. In turn, the number of particles divided by Avogadro's number will tell me the number of moles. So using this as a calculation tool, you should be able to work out these following problems. So pause, take a moment to go through these problems, and now here are the answers for you. 0.12 moles of iron, 7.83 times 10 to the 23 atoms there, 4.2 times 10 moles, so that's 4.2 times 10 moles, and finally we have 9.0 times 10 to the 23 atoms of sodium. So that's how we can do some calculations, and that's quite useful. Now I'm going to introduce something called the molar mass. Okay. The molar mass of a substance is the mass of 1 mole of substance. That is the mass of 6.02 times 10 to the 23 molecules of a substance. So that's the mole of 1 Avogadro's number of molecules. So the number of moles in a substance could be calculated using the formula: the mass of the substance divided by the molar mass tells you how many moles of stuff there is there. Now, it's just important to recognize that this molar mass, this grams per mole, is a value which we're able to find out easily, often using a periodic table. So it's a value which is given, and it's often given as what's known as the molecular mass, or the atomic mass if we're looking at elements. So let's see an example of this. Calculate the number of moles in 64 grams of methane. Okay. Now methane's interesting because it's made of 1 carbon and 4 hydrogens. So that means that I know that the molecular mass of methane is the sum of the atomic mass of 1 carbon, which is 12, and 4 hydrogens, which is 1, which gives me a total of 16. From there I can work out the mass is 64 grams, the molar mass is 16, so 64 divided by 16 gives me 4 moles worth of methane gas. This kind of shows an example of another set of calculations we can do. So this is another calculation triangle, just showing exactly what I just explained. The molar mass, capital M, the mass of the substance, the small m, and the number of moles is going to be n, small n. I'll correct that later. So what we have here is, if we have a calculation, how many moles are in 45 grams of carbon, what we can do is we've got 45 grams divided by the molar mass, and that's going to give me 3.7 mole of carbon. There's two sets of calculations here, and they can be shown in a diagram like this. If I want to find out the number of atoms, I multiply the number of moles by Avogadro's number. If I want to find out the mass of something, I multiply the molar mass by the number of moles. Sometimes if I had the number of atoms, I'd have to work it out into the number of moles and then multiply it by the molar mass to give me the mass of the substance. So if I have a question like, how many atoms in 1.25 grams of sodium, what I'd do is do 1.25 divided by the molar mass of sodium to give me the moles of sodium, and then I'd multiply that by Avogadro's number to give me the number of atoms. And if you do that calculation, you should get 3.27 times 10 to the 22 atoms. So just think, this is the screen which shows all the calculations that you're going to need to do to work out how much stuff there is at a molecular level.